Hi folks, this is just a recap of some of the notes that we did a couple days ago on adding, subtracting, and multiplying polynomials. And then I'm going to do the rest of the problems that we didn't get to, and then you have a Delta Math assignment to be working on throughout the rest of the class period. So in these notes, we were trying to determine how to add, subtract, and multiply polynomials. We started by talking about combining like terms. Remember that like terms need to have the same variable, so letter, and exponent, so the small number at the top that indicates how many times you're multiplying that variable or number by itself. So remember that we can only put like terms together. So these were our answers for 1 through 7. We went on to applying that to a situation where we're adding and subtracting polynomials. So large polynomials. This polynomial has 1, 2, 3 terms, so it's a trinomial. This polynomial has 1, 2 terms, so it's a binomial, and we are adding them. Remember that if you have parentheses, you always want to distribute what is touching the parentheses so that you can get rid of the parentheses. Same idea happens here. The negative would get distributed to all 3 terms, changing all 3 signs of those terms. Notice that the first terms in the first polynomials, those signs don't change. Okay, so we distribute that sign and then we combine our like terms. So you can check your work here if you would like to. I'm going to go ahead and open this up and we're going to look at multiplying binomials. Every class kind of got to somewhere different. I think everybody was able to look at this example, remembering that there's 2 ways to multiply binomials and show your work. One of the ways is FOIL, so it's kind of like double distribution. You're going to take your x, you're going to multiply it by x and by 3, so that's x squared and 3x, and then you're going to take your 7 and you're going to multiply it by x, and you're going to take your 7 and multiply it by 3, and that's the 21 that you see. You combine your like terms and you end up with a trinomial. Now we did try to determine a faster way to do the ones that had just an x and an x and a number and a number. There's a way to do that quickly and with mental math. The first term should be x squared. If you do have any leading coefficients, then you need to multiply them. For example, if this was 2x plus 7 times 3x plus 3, a 2x and a 3x would become a 6x squared. So you'd have to multiply those coefficients. But we don't see that until probably number 6. If you have x times x, that's just your middle term can be determined by adding your constants. 10x is the middle term. And then your last term can be determined by multiplying your constants. So 7 times 3 is 21. So everybody did at least a little bit of, and they did number 1. We're going to look at number 2 and maybe another one. And then we're going to do 5 and 6 together. So on number 2, x times x would be x squared. If I add my constants, negative 6 plus negative 8, that's a negative 14, but the middle term has an x with it. And then to get the third term, we multiply. So negative 6 times negative 8 is a positive 48. So x squared, sum of the constants, product of the constants. So why don't you pause your video, and if you haven't done so already, try number 3 and number 4. So check your work with mine, or your answers with mine rather. First term is x squared, second term is the sum of the constants with the variable beside it, and then third term is the product of the constants. So on number 5, it's a little different. It's not a binomial times a binomial. It's a monomial, so one term, times a trinomial. So there's not really a mental math way to do this. You do need to show your distribution. So 3r times r squared, that's 3r times r times r. So r squared is r times r. That's 3r cubed. I think in some classes we talked about the only way to bump up an exponent from a 2 to a 3 is to multiply by another variable. So now distributing 3r to negative 2r. Positive times negative is a negative. 3 times 2 is 6, and r times r is r squared. And then finally, 3r times 4. Positive times positive is a positive. 3 times 4 is 12, and then the r goes with it. So we should notice that the exponents here have all been bumped up by 1 because that r is being multiplied by each of these terms. And then finally, moving on to number 6. Number 6 looks similar to 1 through 4. The only difference is we have these coefficients of 3 and 2. And so this is not a mental math problem. This is definitely a FOIL or box method problem. So for FOIL, 3x times 2x, 3 times 2 is 6, x times x is x squared. 3x times 5, positive times positive is a positive. 3 times 5 is 15, and then it has an x. Negative 4 times 2x, negative times positive is a negative. 4 times 2 is an 8, and then it has an x. And then finally, negative 4 times positive 5 gives me a negative 20. If I combine my like terms, that would be the x's. Ooh, sorry. They're typically in the middle. So 15x's minus 8x's gives me a positive 7x's. So this is my answer. Okay. So let's move to the right side. The right side helps us to practice a little bit with multiplying polynomials, not using FOIL, but using box method. Box method would give us the same thing, but sometimes box method is more useful for organizing, especially if we're multiplying not binomials by binomials, but maybe binomials by trinomials. So let's flip our page. So in number 7, we have a binomial, 2 terms, times a binomial, times a binomial. So our steps for multiplying multiple polynomials together first requires that we multiply 2 of them together. So you can choose whichever 2 you'd like. You can choose the first 2, you can choose the second 2, you can pick and decide which ones you want to pick based on how easy they are. I might select these 2 because we just did problems that required us to use mental math for something like this, like x minus 5 and x plus 7. So I might do some mental math here. So my first term would be x times x, that's x squared. My second term is the sum of the constants, so negative 5 plus 7 is a positive 2 with an x. And then my last term is the product of the constants, so negative 5 plus 7 is minus 35. So notice that we're still multiplying this binomial out in front by whatever we get here. But now it turns out that we need to organize our math a little bit better. Now, if you didn't use mental math, if you wanted to use the box method, you could certainly do that. And that's what this box is meant for. So just a review on box method. If I were going to multiply these 2 binomials together, I would put each term on a side of the box. So x and minus 5, including its sign, and then x plus 7 here, the x and the positive 7 here. I would multiply the top and the side. So x times x is x squared. X times positive 7 is a positive 7x. I always end up putting my signs here because that helps me keep everything straight. X times negative 5 here is negative 5x. And negative 5 times positive 7 here is negative 35. Your common terms, your like terms, should be in the diagonals. So here, if I add these 2 together, negative 5x plus 7x, that gives me 2x. And so that's my middle term, x squared plus 2x minus 35. Okay, so just a little review on how to use box method. Now, we're at the point where we have a binomial times a trinomial. So I'm going to do the same thing. And box method is great for this because it really helps you stay organized. So I'm going to put my binomial on the side, 2x plus 6. Notice how I keep my sign with the 6. And then I'm going to put the trinomial along the top. So x squared plus 2x minus 35. Now, if you'd like to pause the video here and attempt this problem and then start it back up and skip to where you see the answer, that's perfectly fine. If you'd like to walk through this with me, you're welcome to do that too. So when I multiply these 2 to get this box, this is really a 1x squared. So 1 times 2 is 2, and x squared times x is x to the power of 3. So there's 3 total x's. 1, 2, 3. For the next term, 2x times 2x. Well, that's going to be a positive. 2 times 2 is 4. X times x is x squared. Last box in the top right, I've got 2x times negative 35. A positive times a negative is a negative. 35 times 2 is 70, and then it has an x with it. For this box, 1x squared times 6, well, that's a positive. 1 times 6 is 6, and it has an x squared. These two, 2x times 6, 2 times 6 is 12 with an x. And finally, negative 35 times 6 here. Positive times negative is a negative. 35 times 6 is not something I have memorized, so I might out to the side do 35 times 6. And get negative 210. Now, remember that the like terms should typically be in the diagonals, and so here they are. There's some x squared terms, so 4x squared plus 6x squared is a 10x squared. And then there's another set of like terms. Negative 70x plus 12x gives me a negative 58x. So when I put together all of my terms for my polynomial, I have to include a representation from everything in the box. So 2x cubed kind of represents the x cubed terms. 10x squared represents the x squared terms. Negative 58x represents the x terms. And then the constant term is represented by negative 210. So that's the way I would multiply 3 binomials together. It's also the way that I would multiply a binomial and a trinomial together. So let's go on to number 8. Number 8 says the edge of a cube is 3x minus 2. Find the volume of the cube. So it gives us the edge length, and it wants the volume of the cube. Now a cube looks something like this. And you've learned previously, there we go. You've learned previously that a cube has edges that are all what? They have edges that are all the same. All of the sides have the same length. So if the length is 3x minus 2, that means that the width is 3x minus 2, and that also means the height is 3x minus 2. And if you remember, the volume of a prism is the area of the base times the height. Well, the area of the base is just the area of a square. So the length times the width times the height. So if I substitute 3x minus 2 in place of length and width and height, I end up getting something that looks a whole lot like the previous problem. 3x minus 2 for the length times 3x minus 2 for the width times 3x minus 2 for the height. So you have an example from number 7 on how to multiply 3 binomials together. So I want you to pause your video and try number 8. So the work is split up into 2 sections. First section is multiplying a 3x minus 2 times a 3x minus 2. You get this polynomial right here. So I've inserted that here. Second step is multiplying the binomial times the trinomial. Remember that you end up having like terms that are typically in diagonals. So combining those like terms gave me my final volume answer. All right, last problem, go to number 9. The height of a building is 2x plus 1. The area of the first floor of the building is 3x squared minus 7x plus 2. Find the volume of the building. So again, this building may not be a cube. Building is definitely a rectangular prism. So what they've given us is this floor. They've already multiplied the length and the width together. So we need to determine the volume, which is the height times the length times the width. Well, they already gave us the length and the width. So our height is 2x plus 1, and our area of the base, so our length times our width, is 3x squared minus 7x plus 2. Pause your video and try your answer.